We'll look at the rational exponents. As you recall, when we talk about rational, we're looking at some sort of a fractional item. Okay. Earlier we did rational expressions, and we saw these are any item written as A over B. Today we're looking at specifically with exponents that are written as fractions. Okay. Now, when we did our review for the course, we did talk about some sort of fractional exponents. And if you remember, one of the rules of exponents, or one of the properties of exponents that we looked at was a to the n over m is the same as the mth root of a to the n power. So this here was one of the properties or rules of exponent that we look at. So we'll elaborate more on that rule right now, okay? And then we'll deal with some of the operations with rational exponents. How do we multiply when we have rational exponents? What do we divide? Probably some factoring, okay? So we have been using, or you have been using rational exponents and probably not realizing that you've been using it. And the reason I say that is because when you have the square root of, let's say, 4, okay, you know that this is equivalent to 2, okay? Now this here, okay, all roots or radical, as we call them, can be written using rational exponents. So the key point here is to identify what is the index. This number here is called the index. Okay. So when it's a square root, for square root, okay, there is an invisible 2 as the index. So for square root, there is a 2 there, okay? But generally, we do not write the index when it is 2, okay? So the square root of 4 or 4 raised to the 1/2 power. And the reason I'm going to use some colors here, there's a 2 here. This 2 is the denominator of the fraction. And the power of the number, that's what goes in the numerator. Okay? So that's the rational exponent. We now have 1/2. So likewise, example, the cube root of, let's say, 27. So notice for any other root, cube root, that index has to be written. Square root is the only one that's not written there. So I could write this as 27, okay? Well, since the index is 3, that 3 goes here. And the power of the 27 is a 1, so it's 1/3. Okay. If we look at another example, if we have the 5th root of, let's say, 5 to the 3rd power, or 5, the root is 5th, the index is 5, so that's 5 goes here, and 3 now because the number has a 3rd power trait. So as I said, these numbers here, okay, these numbers is the index of the root. Okay. So in general, we can rewrite any root using rational exponent. Okay, any root. Now that is helpful because sometimes we tend to do things not realizing what we're doing. And the reason I say that is because if we have okay, if we have, let's say, x cubed is equal to 8, okay, and we tend to figure out what is x cubed. Well, we know also that x cubed, if we raise this to 1/3 power, right, if we multiply it by its reciprocal, then 3 times its reciprocal, if you multiply these two based on one of the rules, when you multiply them, x times 3 to the 1/3, which is like 3/1, this becomes 1. Okay. Now if you do that to the left side, you must also raise this here to 1/3 power on the right side. And remember, this here really means the cube root of 8. Meaning, what number, okay, what number when multiplied by itself 3 times gives 8. So you will notice that that number 2 times 2 times 2, so it's 3 times, that number is just 2. And you can see the check, right? If you check, 2 to the 3rd power is equal to 8. So 2 times 2 times 2 is equal to 8, so 8 is equal to 8, and that checks. So the whole point here is to show that we usually do things not realizing what we've been doing. We know that to get rid of a cube on one side, we take the cube root of the other. Or to get rid of a square, we take the square root of it. Okay. So in general, 2 things to review or to recall. Okay. We can review / recall. Okay. One of the properties, a to the n raised to the mth power, is the same as a to the n times m. Or we can say the same as a as m times n. The order here doesn't matter because of multiplication. And I want you to really understand this, right? Because the reason I'm stressing on this is because if we have x squared raised to the 1/2, this is the same as if we say x to the 1/2 squared, because you will multiply, and here you will also multiply. So the order in which we write them doesn't really matter, okay? And you will see later on that by switching sometimes the way we write it, you can make the problem easier for you. Very easy. Okay? So that's something we have to really pay attention to. And you will see that as we do more examples. So suppose I ask you to simplify 8 raised to the 2/3 power. So notice that the denominator here is 3. Okay? The denominator is 3. Okay? So this is a cube root. Okay? This is definitely a cube root. Now, so this can be written 2 ways, right? We could say 8 to the 1/3 power square, or we can say 8 square raised to the 1/3 power. Now, which would be easier, okay? Which will be easier? And pay attention to this very carefully, because 8 square, okay, 8 square means 8 times 8, and then take the cube root of that. And then this here will be 64, and what's the cube root of 64? Well, I'm almost sure you have to think about that to know what the cube root of 64 is. But the cube root of 64 is 4, because if you take 4 and you multiply it by itself 3 times, you will get 64. Now let's look at this, the left side of this, right? The left side of this is the side that I prefer, actually. So this side is the better side. So the cube root, right? Keep in mind this means cube root here. This is cube root. The cube root of 8 is 2, okay? A number when multiplied by itself 3 times. And then if we square that, this means 2 times 2, which is equal to 4. So we get the same answer, but then you don't have to think about large numbers here as you did, right? The number here was very large. Whereas this side, it's not. So generally my recommendation is that it turns out to be less stressful thinking about large numbers, as at the same time you're thinking about fractional exponents, and most of us tend to freeze up when we hear about fractions. So my recommendation would always perform the operation with the root first if you can, okay? Then you don't have to worry about these big, large numbers. So in this example, let's simplify 36 to the 3/2 power. So as we know, we said that this is the same as 36 to the 1/2, then to the 3rd. Or you could write it as 36 to the 3rd power, then take the 1/2 of that. Regardless which one of these you choose, when you multiply these two things, you do get back 3/2, okay? When you multiply them. Well, we know that 1/2 power implies square root. So what's the square root of 36? The square root of 36 is just 6. And then if we raise 6 to the 3rd power, okay, Whereas in this case here, automatically you're going to have to get a calculator. You're basically stuck because we do not know what is 36 times 36 times 36. We need a calculator. Okay? However, going back to this side here, we know that this here means 6 times 6 times 6. Okay? So if we multiply 6 times 6, if we multiply these two, we get 36 times 6. And then if we multiply 36 times 6, that becomes 216. Okay, so this is 216. So let's look at one example with a negative power now. Okay, so simplify 16 to the negative 3/2 power. So we know we can rewrite this. We can rewrite as 16 to the 1/2 and then to the negative 3rd power. Okay, and we know that this here means the square root of 16, which is 4 to the negative 3rd power. Well, we have to also remember what is the negative 3 mean. From our definition that we know that the negative power, okay, the negative power can become positive by putting it in the denominator. And now this becomes 1 over 4 times 4 times 4. If you multiply these two, you get 1 over 16. 16 times 4, which is equal to 1 over 64. So in our course, we will have to be able to look at these fractional exponents and know when to rewrite them as roots, when to rewrite them as fractions. And that will help you a lot if you can quickly transfer between roots and fractional powers. It'll make our life, or make your life, sort of much easier in some sense. You'll be able to work back, go back and forth with these problems at a much faster pace. Okay. So we'll look at more examples as we go through the video. Okay. We'll definitely go through more examples and see what's going on. Now, as a quick reminder, I do want to remind you at this point, because this is something we went over before, that when we look at square roots, for square roots, so you want to recall this, we did talk about this earlier, square roots, okay, we looked at positive numbers only, okay? And I'm still only looking, we'll continue to do this only with positive numbers until we cover the topic called complex numbers. That's when we'll start looking at negative numbers for square roots. So anytime when we say square root, keep in mind square root is an even number, okay? Square, hence the word square, okay? So in general, anytime that index is a 2, you should only be looking at positive numbers. So keep in mind, you can take roots of negative numbers, but for now we're only looking at positive. So what happens if something is negative, we'll talk about that later. But for odd roots, okay, we can have positive or negative numbers. Okay. For example, if I ask you what is negative 8 raised to the 1/3 power? Okay, or this means the cube root of negative 8, right? You should see the link that this is the same. Okay, so the cube root of negative 8, the cube root of 8 we know is 2, so the cube root of negative 8 becomes negative 2. And the reason why is because negative 2 times negative 2 times negative 2 becomes negative 8. So that number we're really thinking about is a negative 2. Okay, negative 2 is the number we're thinking about. And that's not possible when we have square roots, because anytime we multiply two negative will turn out to be a positive. Right? So there is a little trick that we do. We factor out negative 1, which we'll talk about later on. Now, keep in mind that if I ask you, yeah, keep in mind that these two things are totally different also. Example, negative 8 to the 1/3. Okay, this is different. Okay, note, this is different from negative 8 raised to the 1/3 power. Okay, and the reason why, because the negative sign is outside in our example. So what it means here is, first we'll do this part, and this here is the cube root of 8, which is 2, and this negative sign drops down, so the answer becomes negative 2. So in both cases you'll get negative 2, but keep in mind the way the problem is written is totally different. So we can now look at quantities where we're multiplying and dividing using rational exponents. So if you remember, right, and I don't want you to get too tied down or too stuck up on when you see fractional exponent. The procedures are the same as what we have done when they were not rational exponent, okay? So let's just review an example. Okay? We know if we have a to the 3rd times a to the 5th, this becomes a to the, let's spell it out, 3 plus 5, which is equal to a to the 8. Right? When we're multiplying, we add the powers. Okay? That's the rule. When multiplying, the same with the same base, okay, we add the powers, the exponent. Okay, we add the exponents. So that's generally what we do. Okay, and in addition, if we had a to the 12th divided by a to the 5th, this becomes a, and I always tell you to keep it in parentheses, 12 minus the denominator, which is equal to a to the 7th. Okay, so in general, when dividing, okay, with the same base, we subtract the exponents. And be careful when we say subtract, it's always numerator minus denominator. You cannot switch the order, okay? Cannot. So now with that being said, I mean, going back to what we've said, don't get too confused with this. For example, if I ask you, what is x to the 3/2 times, okay, x to the 4/3? Well, since the bases are the same base, okay, this becomes x to the 3/2 plus 4/3, which now becomes, same denominator, x, common denominator will be 6, so this becomes 9/6, and this becomes 8/6, okay, which is now equal to x to the 17/6 power, okay, and there's no need to simplify this, okay, you leave it as an improper fraction, it's okay. Okay. So all of the properties we're looking at will be the same. Okay, another example. Okay, so let's simplify the other example. So notice now we have two bases. We have A's here, okay, and then we have also B's here. So we can look at them individually, right? So if you try to simplify what we have in red, this becomes A 3/4. Since we're dividing, we'll now subtract the denominator, which is 7/8. And then we have B to the 2nd power minus 1/4. And then we have to go and simplify this portion here, and then we'll finish work with that. So this becomes A, the common denominator is 8. Okay, so this is 6/8 minus 7/8, which becomes A to the negative 1/8. And then for B, we have common denominator will be 4. Okay, so this becomes 8, and here is a 1, so this becomes B to the 7/4. Now, unfortunately, you cannot leave negative exponents, right? You should never leave an answer as negative exponent. So this here becomes A, but 1/8 now, 1/8 power, okay? A to the 1/8 power, but in the denominator, times B to the 7/4. And if you want, you can simplify this even further, so you get B to the 7/4 over A to the 1/8. Okay? So I will take either answer for now, either this answer or this answer has the same meaning. Okay? Either one of them is correct. Obviously, I prefer the later one than the second to last step. Let's look at another example. Simplify. If we have x to the minus 4th power, y to the 3/2 power, everything to the 3rd power, divided by x to the 6th power and y to the 3/2 power. Okay. Now remember parentheses first, right? So we have to distribute the outer exponents to all of the exponents on the inside, right? Because there's nothing inside here for us to simplify, right? Inside parentheses first. So since there's nothing in there to simplify, okay, so if we multiply, this becomes x to the negative 12 power and y to the 9/2 power, okay? 3 over 2 times 3. 3 times 3 is 9. And there was like an invisible 1. 2 times 1 is 2. The denominator becomes x to the 6 and y to the 3/2. Now, similarly, as we said before, right, this here is one base, and this here is another base. So we can simplify them as x to the numerator power minus the denominator power, y to the numerator power minus the denominator power. So we don't have any fraction for the x, so this just becomes minus 12 minus 6 becomes minus 18. And for the y's, the denominator is already the same, so it stays. And 9 minus 3 is 6. And 6 divided by 2 happens to be 3. But we cannot leave with negative power, so this becomes 1 over x to the 18th power, y to the 3rd multiplication, which is the same as y to the 3rd over x to the 18th. And this is the answer I would prefer. Questions? So we could look at some more scenarios with rational exponents. Okay. When we're multiplying, okay, we have, for example, x to the 2/3 times x to the 4/3 minus x to the 1/3. Well, I'm sure if this was not fractions, you would have probably said, oh, this was very straightforward. Because we know when we have parentheses, we take what we have on the outside and we distribute it to what's on the inside. And keep in mind, when you distribute, you add the powers, right? So the first part, these two parts here, when you distribute them, it's x to the 2/3 plus 4/3 minus the second part becomes x to the 2/3, okay, plus 1/3. And I'm adding because remember, if you have a square, okay, example, if you have a squared times a to the 3rd, it becomes a to the 2 plus 3. And that's the reason why over here we're adding, okay? We add. So now the denominators are the same, so this becomes x4 plus 2 is 6/3 minus x to the 2, this becomes 3/3. So this is x squared minus x. Okay. The same will happen if you had binomials multiplying by rational exponents. So this does not get any more difficult than what you've known before. The problem is that we're dealing with fractional powers. Okay. Let's look at another example. Example, multiply. Okay. If I have, for example, x to the 1/3 minus 5 times x to the 2/3 plus 5. The same idea. You guys usually call this FOIL. So we multiply it out. What is x to the 1/3 times x to the 2/3? Well, the bases are the same. So it becomes x to the 1/3 power. When we're multiplying, we add. So 1/3 plus 2/3. And then if we multiply again, we have this times this. So we have plus 5x to the 1/3. And if we multiply again, we have this times this, which becomes minus 5x to the 2/3. And then if we multiply the last portion of it, we have this times this. Well, let's use a different color, orange. This times this becomes negative 25. Okay. Now we can combine here. We can combine these two here. So this becomes x. The denominators are the same, so 3 over 3. Okay? Now be careful in the middle. Since this power is different from this power, we cannot combine them. So this stays as plus 5x to the 1/3 minus 5x to the 2/3 minus 25. So you would be able to combine them if the powers were exactly the same, right? If the powers were the same and you multiply them out, then you would be able to add the coefficients or subtract the coefficient. You can only combine them if the powers here has to be the same power. Same power, you can combine. Otherwise, you cannot. So the final answer here we have is x plus 5x to the 1/3 power minus 5x to the 2/3 power minus 25. Okay? And it doesn't matter how difficult I make this, okay? Then you should be able to multiply it out. Now, I want to stress here on an example that I usually see a big mistake on, right? A major mistake when it comes to this example. Suppose I have x to the 1/3 minus 5, quantity squared. So it is very common that since we know of the rules of distributing power on the outside to all of the power on the inside, students tend to do this. But be careful. Keep in mind that anytime the operation between those two quantities is minus or add, you cannot distribute. So what this implies here is x to the 1/3 minus 5 times x to the 1/3 minus 5. That's what it implies. Okay? And now you FOIL it out. You cannot, and I'm gonna write this in red, cannot distribute the outer exponent. Okay? Cannot. So if you multiply these two, you get x to the 1/3 plus 1/3. Then this times this becomes minus 5x to the 1/3. This times this becomes minus 5x to the 1/3. And this times this becomes plus 25. So simplifying this portion here, we get x to the 2/3. Now notice here that the powers are the same, okay? If the powers are the same, then we combine the coefficients. So this becomes minus 10x to the 1/3, right? You add the coefficient plus 25. And this is your final answer. What happens when we are dividing? If we're dividing, the procedure is still the same. Now let's look at divide. If we have, for example, let's say 25x to the 2/3 y to the 1/3 minus 30x to the 4/3 y to the 2/3, all of this divided by 5x to the 1/3 y to the 1/3. Okay, so we know that, and we have talked about, when the denominator is a monomial, you can rewrite this, and this becomes 25x to the 2/3 y to the 1/3 divided by 5x to the 1/3 y to the 1/3 minus 30x to the 4/3 y to the 2/3 divided by 5x to the 1/3 y to the 1/3. And we can divide now because 25 divided by 5 happens to divide evenly. If it doesn't, you leave it as a fraction. So this becomes 5. And then we have the same bases here, okay? So this becomes x to the 2/3 minus 1/3. And then likewise, we have same bases here. So this becomes y to the 1/3 minus 1/3. And we do the same thing for this side now. So minus, I'm going to write it at the bottom here. This portion actually, this portion here happens to go. So we have, we can write that as 6, okay? Then we have x to the 4/3 minus 1/3, and then y to the 2/3 minus 1/3, okay? So I don't like how that is quite squished up over there. So coming down over here, we have 6x to the 4/3 minus 1/3, and then y to the 2/3 minus 1/3. Simplifying, this becomes 5x 2/3 minus 1/3 is 1/3, and y 1/3 minus 1/3 is 0. Minus 6, 4/3 minus 1/3 becomes x to the 3/3, and y 2/3 minus 1/3 becomes 1/3. Now, a few things to remember. What is y to the 0? We said that anything to the 0 power is equivalent to 1, okay? So this becomes 5x to the 1/3 times 1 minus 6x to the 1, because 3 divided by 3 is 1, y to the 1/3. So final simplification step, 5x to the 1/3 minus 6xy to the 1/3. And here is the quotient of the division. So the whole idea of the division is the same as what we're doing also, okay? And you have to be good at division in order to do the factoring of rational exponents also. Okay. So in our next video, we'll look at some factoring. How do we factor with rational exponents? And then we'll move into radicals, okay? How do we simplify radicals? After the simplification of radicals, we'll move on to rationalization. And I think that is all I'll plan to cover for this chapter. Okay, so I'll see you next class.